Imagine a place where the sun never shines, where temperatures plummet to minus 250 degrees Fahrenheit, and where no human has ever set foot. This isn't a scene from a sci-fi movie, it's the moon's dark side. But what if first told you that this mysterious, hidden half of the moon is a hotspot for cutting-edge experiments that could change our understanding of the universe? From testing the limits of technology to searching for the origins of life, the moon's dark side is more than just a celestial curiosity, it's a gateway to groundbreaking discoveries. Stick around, because we're about to explore the secrets and experiments that make this lunar landscape one of the most intriguing frontiers in space exploration. The term dark side of the moon is often misunderstood. It doesn't mean that this side is always dark or hidden from the sun. In fact, the moon's dark side gets just as much sunlight as the side facing Earth. The confusion arises from the fact that the moon is tidally locked to Earth. This means that the moon takes the same amount of time to rotate on its axis as it does to orbit around Earth. As a result, we always see the same side of the moon from our planet. Tidal locking is a bit like a dance between the Earth and the moon. The moon's rotation and orbit are in sync. This is why we never get to see the far side of the moon from Earth. It's not that the far side is permanently hidden, it's just that we can't see it from our perspective. The far side of the moon is sometimes called the dark side because it's mysterious and unknown, not because it lacks sunlight. The far side of the moon is also sometimes referred to as the far hemisphere or lunar far side. It's important to note that the far side isn't always dark. It experiences day and night just like the near side. The only difference is that we can't see it from Earth. The far side of the moon was first photographed by the Soviet Lunar 3 probe in 1959. Since then, several missions have explored this mysterious region, revealing a landscape that's quite different from the side we are familiar with. The far side of the moon has more craters and fewer of the dark, smooth areas called maria that we see on the near side. This is because the far side's crust is thicker, making it more difficult for molten rock to reach the surface and form maria. The far side also has a larger crater called the South Pole Aitken Basin, which is one of the largest impact craters in the solar system. Despite its differences, the far side of the moon is just as much a part of our natural satellite as the side we see every night. The Cold War era was a time of intense rivalry between the United States and the Soviet Union, extending even to the far side of the moon. The hidden lunar territory, never visible from Earth, became a subject of strategic interest for both superpowers. The far side's isolation offered a unique advantage. It was shielded from Earth's radio frequencies, making it an ideal location for secretive military experiments and communications. Both nations recognized the potential of the moon's far side for establishing secure, undetectable military outposts. The United States and the Soviet Union invested heavily in lunar exploration programs, not just for scientific discovery, but also to gain a strategic edge. The far side's mountains and craters provided natural cover for potential military installations. These could serve as listening posts to monitor enemy activities or as launch sites for surprise attacks, all while remaining hidden from Earth's view. The strategic importance of the moon's far side was not just theoretical. Both countries conducted experiments to test the feasibility of establishing military bases there. The US explored the idea of using the far side for early warning systems to detect incoming missiles. Meanwhile, the Soviet Union considered it a prime location for jamming enemy communications. The secrecy surrounding these plans added to the intrigue and heightened the stakes of the space race. The far side's unique environment also presented challenges. The lack of direct communication with Earth required the development of new technologies. Both nations had to figure out how to relay information from the far side, leading to innovations in satellite communication. Despite the technical hurdles, the potential military benefits kept the far side a priority. The Cold War's end didn't diminish the strategic value of the moon's hidden territory. Today, the far side remains a point of interest for military and strategic planning, a silent witness to the geopolitical tensions of the past and a potential player in future conflicts. The far side of the moon, often referred to as the dark side, has always been a subject of fascination and mystery. Its perpetual concealment from Earth's view has sparked numerous scientific proposals, some of which were abandoned or classified due to various reasons. One such idea involved setting up a network of radio telescopes to observe the early universe. The far side is uniquely shielded from Earth's radio interference, making it an ideal location for such experiments. However, the logistical challenges and the high costs associated with transporting and assembling equipment on the moon led to the abandonment of this proposal. Another intriguing but ultimately shelved idea was the establishment of a lunar observatory to study high-energy cosmic particles. Scientists proposed that the far side's environment could provide unparalleled opportunities to detect and analyze these particles without atmospheric interference. The project was scrapped primarily due to the technological limitations of the time and the lack of sufficient funding. The harsh lunar conditions, including extreme temperatures and radiation, also posed significant challenges that were deemed insurmountable at the time. Some proposals were classified due to their potential military applications. For instance, there were plans to use the far side of the Moon as a vantage point for surveillance satellites. The idea was to leverage the Moon's position to monitor Earth's orbit and beyond, providing strategic advantages. Details about these proposals remain scarce, but it is known that they were abandoned or remain highly classified due to the sensitive nature of the information involved. The far side's isolation and the difficulty of maintaining secret operations on the lunar surface likely contributed to the decision to shelve these ideas. In addition to these, there were also proposals to conduct experiments on the far side to study the Moon's internal structure. Scientists wanted to place seismometers to detect moonquakes and gather data about the Moon's core and mantle. The far side was considered ideal because it would allow for a more comprehensive study of the Moon's geology without interference from Earth-based activities. However, the complexity of deploying and maintaining such equipment on the far side led to the project being put on hold indefinitely. The lack of immediate practical benefits also played a role in the decision to abandon this proposal. The far side of the Moon is a unique place. It's always facing away from Earth, which means it's shielded from our planet's radio transmissions. This makes it an ideal spot for deep space signal observation. The lack of man-made radio interference allows for a much clearer view of the universe. Scientists have taken advantage of this. They've set up experiments to listen for weak signals from distant stars and galaxies. These signals are often drowned out by noise on Earth, but on the far side of the Moon, they can be heard clearly. This has led to some exciting discoveries. For example, astronomers have been able to detect faint signals from the early universe. These signals can tell us about the conditions that existed just after the Big Bang. The far side of the Moon also offers a unique opportunity to study the Sun's solar radio bursts can be difficult to observe from Earth. Our planet's atmosphere and ionosphere can interfere with the signals. But from the far side of the Moon, these bursts can be observed without any interference. This can help scientists better understand the Sun's activity. It can also help us predict space weather events that can affect satellites and power grids on Earth. There are challenges to working on the far side of the Moon. Communication with Earth is difficult. Signals can't be sent directly. Instead, they have to be relayed through a satellite orbiting the Moon. This adds complexity and can introduce delays. But despite these challenges, the benefits of working on the far side of the Moon are clear. It's a unique environment that offers unparalleled opportunities for deep space signal observation. As technology advances, we can expect even more exciting discoveries from this fascinating place. The far side of the Moon, often referred to as the dark side, is a place shrouded in mystery. It's not actually dark, as it gets just as much sunlight as the side facing Earth, but it's far less explored. This remoteness has sparked intriguing rumors and theories, particularly about alleged biological tests and life exposure experiments. Some speculate that the Moon's far side could have been used for secretive biological experiments due to its isolation from Earth's view. One of the most persistent rumors involves the idea that certain countries or organizations might have conducted experiments to test the effects of space radiation and the lunar environment on various forms of life. The far side of the Moon is an ideal location for such experiments because it's far from prying eyes and Earth's magnetic field, which protects us from solar and cosmic radiation. This makes it a unique environment to study the long-term effects of radiation on living organisms. However, it's important to note that these are largely speculative ideas, as there is no concrete evidence to support them. Another angle to consider is the potential for accidental contamination. When spacecraft or landers are sent to the Moon, they can carry microorganisms from Earth. These microbes could potentially survive and even thrive in certain lunar conditions. While this isn't necessarily a deliberate experiment, it does raise questions about the potential for life to exist or be introduced to the Moon's environment. The far side, with its unique conditions, could provide valuable insights into how life might adapt and survive in such an environment. Despite the intriguing nature of these rumors, it's crucial to approach them with a critical eye. The far side of the Moon is a harsh and unforgiving environment, and conducting biological experiments there would be fraught with challenges. Moreover, any such experiments would likely be subject to international space treaties and agreements, which emphasize the peaceful use of outer space. While the idea of secret biological tests on the moon's far side is fascinating, it remains largely in the realm of speculation. The far side of the moon, often referred to as the dark side, presents a unique and formidable challenge for infrastructure development. Unlike the near side, which is visible from Earth, the far side is shielded from direct radio signals, making communication with equipment there much more difficult. This isolation necessitates the use of relay satellites, adding complexity and cost to any mission. For instance, China's Chang'e 4 mission, which successfully landed a rover on the far side, required the deployment of the Kukiao relay satellite to facilitate communication. This extra step highlights the logistical hurdles involved in maintaining contact with equipment on the far side. Extreme temperature fluctuations also pose a significant challenge. The moon's surface can reach scorching highs of 127 degrees Celsius (260 degrees Fahrenheit) during the day and plummet to minus 173 degrees Celsius minus 280 degrees Fahrenheit at night. These drastic changes can cause materials to expand and contract, leading to structural fatigue and potential failure. Equipment must be designed with materials that can withstand such extremes. For example, thermal control systems are crucial to regulate the temperature of sensitive instruments. Without proper insulation and heating mechanisms, electronic components can quickly degrade or become inoperable. The Apollo missions provided valuable data on these temperature extremes, but the far side's unique environment requires even more robust solutions. Dust is another major obstacle. Lunar regolith, or moon dust, is abrasive and can damage equipment over time. It sticks to surfaces, clogs mechanisms, and reduces the efficiency of solar panels. On the far side, the lack of direct Earth-based monitoring makes it even more challenging to assess and mitigate dust-related issues. Engineers must develop innovative solutions, such as electrostatic dust removal systems or self-cleaning surfaces, to ensure the longevity of equipment. The abrasive nature of lunar dust was a known issue during the Apollo era, but the far side's environment exacerbates the problem due to the absence of direct oversight and maintenance. Power generation is yet another hurdle. The far side experiences long periods of darkness, lasting about 14 Earth days, during its lunar night. Solar power, which is a primary energy source for lunar missions, becomes unreliable during these extended nights. Alternative power sources, such as nuclear batteries or advanced energy storage systems, are being explored to ensure continuous operation. For example, radioisotope thermoelectric generators, RTGs, have been used in space missions to provide a steady power supply. However, these solutions are often heavy and expensive, adding to the overall complexity of the mission. The far side's unique environment demands creative and resourceful approaches to power generation and management. The term dark side of the moon often sparks intrigue. It's not actually dark, but it's the side we can't see from Earth. Over the years, various missions have explored this mysterious region. Some of their findings, or rather, the lack thereof, have fueled wild speculation. Declassified documents, often fragmented and incomplete, have only added to the mystery. One notable example is the Lunar 3 probe, launched by the Soviet Union. It sent back the first images of the moon's far side. However, the quality was poor, and the images were grainy. Conspiracy theorists latched onto this, suggesting that the Soviet Union had hidden something. They claimed the images were deliberately obscured to conceal unusual structures or even signs of extraterrestrial activity. Of course, this is pure speculation. The poor image quality was due to technological limitations of the time. Then there's the Apollo 8 mission. Astronauts orbiting the moon reported seeing strange lights on the lunar surface. Declassified transcripts of their communications reveal this. Some fragments of these transcripts have been taken out of context. They've been used to support claims of secret moon bases or alien activity. In reality, the astronauts were likely seeing light reflecting off lunar terrain or even their own spacecraft. Another intriguing case involves the Clementine mission. This was a joint project by the US Department of Defense and NASA. It mapped the moon's surface in great detail. Some declassified images from this mission show unusual features. These have been pointed to as evidence of artificial structures. However, scientists explain these features as natural geological formations. The human brain is wired to see patterns, even where none exist. This phenomenon, known as pareidolia, explains why some people see faces in clouds or animals in rock formations. The same applies to these lunar images. The lack of complete context in declassified documents often leaves room for interpretation. This is especially true when the documents are fragmented or redacted. It's important to remember that these documents are often summaries or notes. They're not always intended to provide a full picture. Yet, this is precisely what makes them so tantalizing to conspiracy theorists. They fill in the gaps with their own interpretations, often leading to outlandish theories. In recent years, the release of declassified documents has become more common. This is due to policies aimed at increasing government transparency. While this has led to some interesting revelations, it has also fueled more speculation. The moon's dark side remains a source of fascination and mystery. Until we have more complete and clear information, the conspiracy theories will likely continue to thrive. After all, the unknown has always been a fertile ground for the imagination. The far side of the moon, often referred to as the dark side, has always been a subject of intrigue. Recently, there's been a surge in interest and activity focused on this enigmatic lunar region. Several space agencies and private companies are planning or already executing missions to explore the far side. China's Chang'e 4 mission, for instance, made history by successfully landing a rover on the far side. This mission aims to study the geology of the region, which is quite different from the near side. The far side is more rugged and has a thicker crust, making it a fascinating area for scientific exploration. One of the primary reasons for the renewed interest is the unique environment of the far side. Unlike the near side, which is tidally locked and always faces Earth, the far side is shielded from Earth's radio interference. This makes it an ideal location for radio astronomy. Scientists hope to place radio telescopes on the far side to observe the early universe without the noise from Earth. Additionally, the far side's craters and highlands offer a wealth of information about the moon's formation and the solar system's history. By studying these features, researchers can gain insights into the processes that shaped our celestial neighborhood. However, exploring the far side comes with its own set of challenges. Communication is a significant hurdle. Since the far side is always facing away from Earth, direct communication with missions on the far side is impossible. To overcome this, China launched the Quqiao satellite, which acts as a relay station, enabling communication between the far side missions and Earth. This technology is crucial for the success of any mission aiming to explore the far side. Future missions will likely rely on similar relay systems to maintain contact with Earth. Despite the advancements, many questions remain unanswered. The far side's unique geology and environment raise numerous scientific queries. For example, why is the far side's crust thicker than the near side? What can the far side's craters tell us about the early solar system? How can we best utilize the far side's radio-quiet environment for astronomical observations? These questions drive the renewed interest and missions to the far side. As technology advances and more missions are planned, our understanding of the far side will undoubtedly deepen, shedding light on the mysteries of the moon and beyond. As we wrap up our exploration of the moon's dark side experiments, let's recap what we've discovered. We've learned that the far side of the moon, often called the dark side, is not actually dark. It gets just as much sunlight as the side we see. But it is mysterious, with a surface covered in craters and a unique environment that scientists are eager to study. Experiments conducted there have given us insights into the early solar system, the origins of the moon itself, and even the potential for future human exploration. Imagine standing on the far side of the moon, looking up at a sky filled with stars, unobscured by Earth's atmosphere. It's a place of untold possibilities, a frontier waiting to be explored. The experiments we've talked about today are just the beginning. They pave the way for future missions that could unlock even more secrets of our lunar neighbor. We'd love to hear your thoughts on this. What fascinates you most about the moon's dark side? Share your ideas and questions in the comments below. And if you're as excited as we are about the future of space exploration, don't forget to subscribe to our channel. Together, let's keep exploring the wonders of our universe. Until next time, keep looking up.